Now we're going to look at how we can use this factor theorem to help us find all of the solutions to a polynomial, okay? Or solutions meaning zeros, roots, x-intercepts. So this says find all zeros for f of x equals 15x cubed plus 14x squared minus 3x minus 2, given that negative 1 is the root of f of x. Okay? Well, notice if we look at our original polynomial, I have no way, normally when we're solving for roots, solutions, or zeros, we factor, but I don't have a way that I know to factor this. So then I'm just stuck. So now we know that negative 1 is a root. Well, we just used our remainder theorem and by extension our factor theorem, and we can say, well, if I synthetically divide by this negative 1, I'll get that the remainder is 0. Okay? So let's do that. So it's not written as a factor, so I keep the sign the same. So negative 1, and then I look at my polynomial. We've got cubed, squared, 1, none, so I'm not skipping any powers, so I just write it as is with the coefficients, so 15, 14, negative 3, and negative 2. Right? So I bring down the 15. So we're going to do negative 1 times 15 gives us negative 15. Then I'm adding straight down, so 14 plus negative 15 gives us negative 1. Then I'm doing negative 1 times negative 1 is a positive 1. Then I'm adding straight down, so we have negative 3 plus 1 gives me negative 2. And then we're multiplying negative 1 times negative 2 is a positive 2. And then I'm adding straight down, and I'm like, oh good, I didn't mess anything up because I get a 0. I should be expecting a 0 because it told us that negative 1's a root. So I should anticipate that this remainder is 0. Well, we know from our synthetic division that if we divided by this, then I can write what this polynomial is that's left over for when we divided. So we knock this power down by 1, since we were doing an x cubed divided by an x amount. So when I knock it down by power, that's going to be x squared, x, and then x to the 0. And then this is our remainder, which notice our remainder is nothing, which means it goes in evenly. So I have 15x squared minus x minus 2 is our leftover polynomial. Well, if I'm trying to find the zeros, remember that this is a quadratic, and we know how to solve a quadratic, right? So that means that I can look and see, well, can we factor? So I'm doing negative 2 times 15 is negative 30, and I'm adding to negative 1. Right? So I'm looking to see what my factors are here. So we can do 5 and 6, with the 6 being negative. I double check my signs. 5 times negative 6 is negative 30. 5 plus negative 6 is really negative 1. Okay. I pay back the 15 on both of these, and then I find any common factors. So 15 and 5 have a common factor 5. 5 goes into 15 3 times, 5 goes into 5 once. 15 and 6 have a common factor of 3. 3 goes into 15 5 times, 3 goes into negative 6 2 times, and I keep the negative. So then this will factor to 3x plus 1 times 5x minus 2. And remember, since we're solving for 0, or we're solving for our roots, or our solutions, or zeros, or x-intercepts, all of those, then I'm setting it equal to 0, because that's our pattern for finding our zeros, because you set it equal to 0 and you solve. So that means here, if I set this equal to 0, that means I change the sign of this one, divide by this one, so that gives us negative 1/3. And then I change the sign here and divide by this one, so that gives us 2/5. And then don't forget this one, because this one was a factor as well of negative 1. Right? So then all of these are our x-intercepts. And notice each one of them showed up one time, right? So that means the multiplicity on each one of these is 1, which means I now know all of these are odd and crossing, right? Which means I can make a general pretty great sketch of my graph, right? We know it's happening at negative 1/3, at 2/5, you see that's about there, and at negative 1, all of them are crossing. If I go back up and I look at my polynomial, it's an x cubed, which means it's odd, so it's discoing. So since it's a positive 15, that's going to be increasing from left to right. Okay. If I plug in 0 into here, notice all of those will go to 0, and I'm left with negative 2. So I also know my y-intercept is negative 2. So my y-intercept is negative 2, and I know that it's discoing positive end behavior, so I'm going to come from the bottom left, cross, 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 and I have a pretty decent sketch of my polynomial.